Hi, welcome to my channel pibyme Maths. This is Devan. Here we are solving January-February 2025 for the Pure Math 1 Pastpaper. In the previous video, we have covered question number 1 to 5. Let's look at question number 6. The rectangular hyperbola H has equation this. The point P of 10t, 10 over t where t is not equal to 0 lies on H. Part A, use calculus to show that the normal, that means they want us to find the equation of the normal in this format. To find the equation of the normal, you need to find the slope first. So make y as a subject, 100 over x or 100x power minus 1. Differentiate it first. So we'll get minus 100x power minus 2 or minus 100 over x square. Sub in the x coordinate here, so you will get the slope of the tangent. Slope of the tangent is minus 100 over 10t whole square. 10 square and 100 will be cancelled. You will get minus 1 over t square. So normal is a line perpendicular to the tangent. So the slope will be negative reciprocal of this, which is positive t square, right? So we have a slope, we have a point. Take the point as x1, y1. So the equation is y minus y1 is equal to slope times x minus x1. That's the equation. Now they want us to write the equation in this format. Okay, here copied the equation here. Now to get it, we need to write it in this format. So to get rid of the fraction, I'm going to multiply through it by t. I will get yt minus 10 is, here when you multiply by t, t cube x minus 10t. Open the bracket, you will get t cube x minus 10t power 4, which is yt minus 10. So bring the yt this side, 10t power 4 this side. You'll get 10t power 4 minus 10 is t cube x minus ty. Therefore, t cube x minus ty is, take 10 as a common factor. And we got the answer already. That's all. So it's a 4-mark question. Let's move on to part B. The normal to H at P meets the y-axis at point Q. This is the normal to H. T cube x minus ty is 10 times t power 4 minus 1. So if it meets at y-axis at Q, if it meets y-axis at Q, replace x by 0 to find the point. So this becomes 0 minus ty is 10 times t power 4 minus 1. Y is going to be 10 times t power 4 minus 1 divided by minus t. Multiply both numerator and denominator by negative 1. You will get 1 minus t power 4 over t. So the point Q is, x coordinate is 0, y coordinate is 10 times 1 minus t power 4 divided by t. So we got the point P already. We got the point Q here. We know the point P from the question, from the previous part. Now let's draw a little diagram to understand this. They are talking about area of the triangle OPQ is 750. We need to find both possible pair coordinates of the point P. So I'm going to draw a little diagram to understand this. We know point P is 10t, 10 over t. So but in the question that the value of t is not mentioned. All they mention here in the question, t is not equal to 0. So t can be any real number. It can be positive, negative or anything. We don't know. We are not sure, right? So just draw a rough diagram. So let's assume the point Q is here. So this length will be the y coordinate of the point Q, right? But we don't know whether it's a positive number or negative number. So we'll take the modulus of this. So this length is going to be modulus of 10 times 1 minus t power 4 divided by t. If you don't know what modulus is, even if it's a negative number, we take it as positive. Modulus of minus 5 is just 5. Modulus of 5 is also 5. It will change everything to positive. So why we are taking it as modulus? Because we don't exactly know whether t is positive or negative. So we don't know whether this is a negative number or positive number. So we take it as modulus. And let's say p is here. P of 10t comma 10 over t. Origin is here. Let's complete this triangle. So now the base, the area of the triangle is half times the base modulus 10 times 1 minus t power 4 divided by t times the height. Height is this. Again, we don't know whether t is positive or negative. So this is the x coordinate 10t. We are going to take it as modulus 10t. So write it as modulus 10t. This is what given us 750 in the question. Okay, the modulus t can be cancelled. 2 and 10 can be cancelled. 5 times 10 is 50. 50 goes to the other side. You will have modulus 1 minus t power 4 is 750 divided by 50. So you get 15 now. So we have put a modulus here because this can be a positive number or negative number depending on the value of t, right? So I'm going to take both cases. I'm going to take it as positive and I'm going to take it as a negative without the modulus sign and solve both separately. Here when you solve, you'll get t power 4 is minus 14, which is not possible. Anything power 4, t power 4 is basically t square whole square. Square of anything will always be positive. So that's not possible. Here, minus 1 plus t power 4, t power 4 minus 1 goes to the other side, 16. So t will be plus or minus 2. Fourth root of 16 is 2, but you need to put plus or minus 2. Now, go back to the question. They want us to find possible pair of coordinates of point P. We know point P here. When you sub in plus 2 and minus 2, you will get two possible coordinates of P. So we know T is plus or minus 2 and P is 10t comma 10 over t. So when you take t is equal to positive 2, P will be 20 comma 10 over 2. If t is negative 2, p is going to be negative 20 comma negative 5. That's all. Question number 7. We have a matrix A given. Describe fully the single transformation represented by matrix A. So I have copied the two transformations given in your data booklet. The first one is rotation about origin O anti-clockwise. And the second one is reflection in the line y is equal to tan theta x. So how do we know which one is this? If these two numbers are same, it's probably the first one. You see, these two numbers are same, right? And these two numbers, these two elements will have negative opposite signs actually. Look at it. One is negative, another one is positive. So definitely it's the first one. So how do we find the theta? Look at these two, cos theta and sin theta. These two elements are this, right? Equate them. So we know cos theta is minus half, sin theta is minus root 3 over 2. Now, first I'm going to use my calculator, and you can use degree or radian mode. Degree mode. Cos inverse of 1 over 2 is 60. So we know cos 60 is 1 over 2. You can find sin 60, you will get root 3 over 2. Both are positive, but here both are negative. Since both are negative, the theta should be in here. You must have learned this ASTC diagram. In the third quadrant, both cos and sin will be negative. So this is 180, this should be 180 plus theta here. So that tells us theta is equal to 240 degree, 180 plus 60. So you can write, these are all just for your reference. So first you can write theta is 240. So minus 1 over 2 minus root 3 over 2 root 3 over 2 minus 1 over 2 is equal to. So if you find sine 240, you will get this cost. You can verify that actually. Cos 240 degree minus of sine 240 degree minus root 3 by 2. Okay. So you can write it as cos 240 sine 240 minus sine 240 cos 240. So what transformation is that? Is this? It's a rotation of 240 degree anti-clockwise about the origin. That's all. 2 mark question. Let's move on to part B now. The matrix B represents a stretch scale factor 2 parallel to x-axis. Okay, you need to know this actually. If you have a transformation A0, 0B, this is a stretch by scale factor A parallel, this is stretch by scale factor A parallel to x-axis, and stretch by scale factor B parallel to y-axis. Okay, but in this question it says matrix B represents a stretch by scale factor only parallel to x-axis. So in that case B should be just 1, and the scale factor this is, so that's the matrix B. Now if the same question says B represents a stretch of scale factor 5 parallel to y-axis, it should be 1 0, x should be 0, sorry, x should be 1 0 5. This should be the matrix. But if they say both scale factor 2 parallel to x-axis, scale factor 5 parallel to y-axis, it should be 2 0 0 5. Remove that. So in this case you can just write B is equal to 2 0 0 1. That's all. Part C now. A transformation represented by matrix B followed by the matrix A is the transformation represented by C. C is B followed by A. So it's basically AB. Don't write it as BA. So we know matrix A from the question. It's minus 1 over 2, minus 1 over 2, minus root 3 by 2, root 3 by 2. That's from part A. And from part B, B is 2 0 0 1. You just need to do matrix multiplication here. So take the first row, multiply by the first column. Minus half times 2 is minus 1. The second element is 0. And then multiply by the second column. So we'll get 0 plus root 3 over 2. Now take the second row, multiply by the first column. So you will get just minus root 3. Multiply by the second column. Root 3 or minus root 3 over 2 times 0 is 0. Minus half times 1. This is the matrix C. So double I now. M is equal to k minus 2 minus 1 to k, where k is a constant. Given that the transformation represented by matrix M maps the point k comma k onto the point 35 comma 91. If this matrix maps a point to another point, you can frame this equation k minus 2 minus 1 to k, that's a transformation, multiplied by the point is equal to the transformed point. That's all. And apply matrix multiplication here. Take the first row, multiply by the first column here. So k square minus 2k equated to 35, and then if you take the second row multiply by the first column, you are going to get minus k plus 2k square is equal to 91. We need to solve these two quadratic equations separately and find the common point, common value of k that satisfy both of these equations. So the first one is k square minus 2k minus 35 is 0, and 2k square minus k minus 91 is 0. I'm gonna straight away solve it using the calculator. 1 minus 2 minus 35. You get 7 minus 5. K is 7, k is minus 5. So you can write it as k minus 7 times k plus 5 is 0. And when you solve the second one, 2 negative 1 minus 91. 7 and 13 minus 13 over 2. K is 7, k is minus 13 over 2. So write a step here. K minus 7, 2k plus 13 is 0. So there are four values. The only value that can satisfy both equations is k is equal to 7. So you can finally write, therefore k is equal to 7. Let's move on to the next one now. A quadrilateral Q is transformed to another quadrilateral Q dash by the matrix M. Okay, which one is the matrix M? It's given here. K minus 2 minus 1 2k. K minus 2 minus 1 2k. This transformation transforms a quadrilateral Q into Q dash. Now the area of Q dash is given 336 square units. Use the value of k found in part 2. The value of k found in the previous part is 7. So M is basically 7 minus 2 minus 1, 2 7s are 14. Let's find the determinant value of M. Multiply these two. 7 times 14 minus 1 times minus 2. That's how we find the determinant value, right? So it's going to be 7 times 14 minus 1 times minus 2 is positive 2. So you get 96. Why we need a determinant value here? Whenever you apply transformation, that's a area scale factor 96. So if you take the area of Q, multiply by this scale factor, you will get the area of the transformed figure. So this is given as 336 actually. The area of the transformed quadrilateral. So to find the area of the original actual Q, you need to divide by 96. So 336 divided by 96 is 7 over 2 square units. Just put it as 7 over 2 or 3.5 square units. Question number 8. Part I. Prove by induction that for n belongs to positive integers, this is equal to this. So for prove by induction, first you need to prove it for n is equal to 1. For n is equal to 1, find the left hand side. So you will get minus 2, 9, minus 1, 4 to the power 1 is minus 2, 9, minus 1, 4, right? It's the same matrix. Let's find the RHS now. Replace n by 1 here. So you're going to get 1 minus 3, 9, minus 1, 3 plus 1 is equal to minus 2, 9. You are getting the same matrix. LHS is equal to RHS. That's step number 1 in prove by induction. You have to prove the equation for n is equal to 1. Step 2, assume that it's true for n is equal to k. You need to assume that it's true for n is equal to k. So replace n is equal to k in the whole equation. So minus 2, 9, minus 1, 4 to the power k is equal to 1 minus 3k, 9k, minus k, 3k plus 1. That's step number 2. In step 1, you are proving the equation for n is equal to 1. In step 2, you need to assume that it's already true for n is equal to k. In step 3, that's the main one, we are going to prove the result, this one, for n is equal to k plus 1 and write the conclusion. So here I copied the result for k. Now for n is equal to k plus 1. I'm going to start from the left hand side of the original expression. This expression, I'm going to replace n by k plus 1. So minus 2, 9, minus 1, 4. Minus 2, 9, minus 1, 4 to the power k plus 1. I can write this as two matrices actually. Minus 2, 9, minus 1, 4. Minus 2, 9, minus 1, 4. Power k and power 1. Okay. We know power k can be written in this format, right? So I'm going to replace the first matrix by 1 minus 3k, 9k, minus k, 3k plus 1. So I replace this by this, and this one I'm going to keep it as the same because it's power 1. So minus 2, 9, minus 1, 4. And then I'm going to apply the matrix multiplication now. Take the first row, multiply by the first column. So minus 2 times this, it's going to be minus 2 plus 6k. And then multiply by the second column. 9 times 1 minus 3k plus 36k. Right? And then take the second row, multiply by the first column. 2k plus k, right? Sorry, not plus k. K minus k times the first element, this times the second element. So it's going to be 2k minus 1 times 3k plus 1. Now multiply the second row by the second column. Minus 9k plus 4 times 3k plus 1. Now I'll tell you what I'm trying to do here. Our objective is to prove the given statement, right? This is the statement, given statement. So if you have n here, you need to have 1 minus 3 times n, 9 times n, minus n, 3 times n plus 1. So if you have, instead of n, if you have k plus 1 here, that's what we are doing here. We have taken it as k plus 1. We need to prove it can be written it as 1 minus 3 times k plus 1. Did I change everything to k plus? Yes. And then 9 times k plus 1 minus of k plus 1, 3 times k plus 1 plus 1. If you can write it in this form, it looks exactly like this where n is k plus 1. So it's proved already. So that's what I'm trying to do here. After multiplication, I noticed something here. When I multiplied the first row by the first column, I should have multiplied these two, that's here, but I missed out this actually, 9 times k. So I'm gonna write it here, minus 9k. I missed out that part actually. So let me just simplify it and see what's happening. Minus 2 minus 3k, minus 2 minus 3k. And then when I open the bracket, 9 3s are 27, minus 27, 36 minus 27 is 9k. I will get 9 plus 9k. When I simplify this, I'm gonna get minus 1 minus k. When I simplify this, 4 3s are 12, so 12 minus 9 is 3k plus 4. So I got this matrix. So now I ended up getting this matrix, but what we need to prove, this matrix can be written in this form, actually in this form where n is k plus 1. Probably I'll copy this first. Okay, I copied it here actually. We need to write this matrix into this form where n is k plus 1. In the place of n, you need to have k plus 1. You see how I am doing it. This one, if I take minus, I can write it as minus of k plus 1. That looks exactly like minus n, right, where n is k plus 1. Here 3k plus 4. Can I write it as 3k plus 3 plus 1? So 3 times k plus 1 plus 1, does it look like 3n plus 1 where n is k plus 1? So I can write it as 3 times k plus 1 plus 1. And then this one, if I take 9 out, I'll have k plus 1. That looks exactly like 9n, right? And then how about the first one? If I write minus 2 as, I'm going to write minus 2 as it is, minus 3k as minus 3 times k plus 1. So when you open the bracket, you have one extra minus 3, so I'm going to put plus 3 here. Hope you understand this step. So 3 minus 2 is 1. You can write it in this form actually. So it's 1 minus 3 times n. Right? You just need to verify. You don't need to show how you rearranged all this thing. You just need to make sure when you simplify this, you should get this. When you simplify this, you should get this for all the 4 elements. So you need to write is equal to RHS. And then write, that's all. We need to write the conclusion. Now, what is the conclusion? Just write this whole thing. For n belongs to z plus, therefore, for n belongs to z plus, minus 2, 9, minus 1, minus 2, 9, minus 1, 4, to the power n is equal to 1 minus 3n, 9n, minus n, 3n plus 1. Hence proved. That's how you write the conclusion. That's all. So this is basically a 5-mark question. Double I now. A sequence of numbers is defined by u1 is 1, u2 is 4, un plus 1 is this. A iterative formula. Prove by induction that for n belongs to all the positive integers, un is this. Okay. This is slightly different from the previous one. In the previous one, they just want us to prove this statement, right? But here, you are given some statements which are already proven. So we are going to take all these statements are true because it has been already proven already. Okay. Using that, we have to prove this. This has not been proven yet. We are going to prove this. So whenever you want to take something as true, you can start from here actually. Okay. So I'll show you how to do that. We know here u1 is 1, u2 is 4. So we need to find u1 and u2 here. You should get 1 and 4. So n is equal to 1. u1 is 3 power 1 minus 2, 1 plus 2, which is 3 power minus 1 times 3 is 1. For n is equal to 2, u2 is 3 power 2 minus 2, which is 0. 3 power 0 is 1. So we proved already, right? This statement is true for n is equal to 1, n is equal to 2. How do we know it's true? Because we got the same value as this one, right? Okay, so that's step 1. Now step 2, we are going to assume that this is true for k. Assume that it's true for n is equal to k. That means uk is 3 power k minus 2 k plus 2, right? And usually we will prove that for n is equal to k plus 1, right? So when you put k plus 1, you are only getting uk plus 1, but this is given as, think of it like k, you have uk plus 2. So we are going to make two assumptions here. Assume that it's true for n is equal to k and n is equal to k plus 1 also. So uk plus 1 is, replace n by k plus 1 here, 3 to the power k plus 1 minus 2 is going to be k minus 1, and then k plus 1 plus 2 is k plus 3. Okay, we have proved that for n is equal to 1 and 2. We assume the statement is true for n is equal to k and k plus 1. Now we need to prove it for k plus 2 now. Now for n is equal to k plus 2. So for n is equal to k plus 2, what we need to prove? We need to prove that uk plus 2 is equal to 3 power k plus 2 minus 2, which is k. K plus 2 plus 2 is k plus 4. This is what we have to prove. Okay? But we cannot start from here. We need to start from the known statement, which is this. So for in this relation, what would be uk plus 2? But uk plus 2 is 6 uk plus 1 minus 9 uk, right? We are going to take the result of these two already proven results, uk plus 1, uk, and sub in there. So when you sub in, you are going to get 6 times uk plus 1, which is 3 power k minus 1 k plus 3. 3 power k minus 1 k plus 3 minus 9 uk. uk is 3 power k minus 2 k plus 2. 3 power k minus 2 times k plus 2. Okay. Open the bracket and take 3 power k as a common factor. So you will get 6 times 3 power minus 1 times k plus 3 minus 9 times 3 power minus 2 times k plus 2. So you're going to get 3 power k. 3 power minus 1 is 1 over 3. So 6 times 1 over 3 is 2 times k plus 3 minus 3 power minus 2 is 9. 9 will be cancelled. K plus 2. Hope you understand this step. Open the bracket, so you will get 3 power k times 2k plus 6 minus k. So 2k plus 6 minus k minus 2. You will get 3 power k times k plus 4, which is what we need to prove. Right? Which is what we need to prove. So we can just write the conclusion. So now we need to write the conclusion. The conclusion is, therefore, for n belongs to z star, un is equal to this. Just write the conclusion at the end and finish it off. That's it. Question number 9. The parabola C has equation y square is this, and the point is given lies on C. Use calculus to find the equation of tangent in this format. So 3 mark question. So we need to find dy by dx first. So you can write it as, if you know implicit differentiation, you can apply implicit differentiation, which is basically 2y dy over dx is equal to 1 over 2. You can do that. Or if you haven't learned that implicit differentiation is in pure math 4, you can just make y as a subject here. So y is going to be square root of 1 divided by square root of 2 times square root of x. So dy over dx is half x power half minus 1, which is 1 over 2 root 2 times 1 over square root of x. Now the slope of the tangent is, in this dy by dx, sub in the x coordinate of the point. So 1 over 2 root 2 times the x coordinate is t square over 8, 1 divided by square root of t square over 8. Okay, when you put the square root separately, square root of t square is t, square root of 8 is, you put it in your calculator, square root of 8 is 2 root 2. So the 2 root 2, 2 root 2 can be cancelled. So you will just get 1 over t. That's the slope of the tangent, and in fact we are finding the equation of the tangent. So use the same slope and this point as x1, y1. So the equation is y minus y1 is equal to slope times x minus x1. Now we need to write it in the required format. Since there is no fraction here, I'm going to multiply through it by 4t. I'm going to multiply through it by 4t. So it's going to be 4ty minus t, 4 will be cancelled, I'll get t square is equal to tt will be cancelled, 4 times x minus t square over 8. Multiply through it again by 2 to get rid of the fraction. You'll get 8ty minus 2t square is, when you multiply this by 2 it becomes 8, and open the bracket you'll get 8x minus t square. So put the 8x this side, this side, and you got the equation already. Therefore 8yt minus 8x is equal to t square. It's a 3-mark question. Part B now. There are a lot of information, so let's read it carefully. Given that the tangent to C at P meets y-axis, this is the equation of tangent to C at P. 8yt minus 8x. 8yt minus 8x is equal to t square. This line meets the y-axis at point A. So to find point A, you need to replace x by 0. You will get, this becomes 0. 8yt is t square. Y is going to be t square over 8t, which is t over 8. So the point A is 0, comma t over 8. Okay, and then there are two lines L1 and L2. Let's talk about L1 first. L1 is perpendicular bisector of OA. O is the origin. Okay, we don't know whether we need the equation or not. Let's read the question further. The line L2 is a perpendicular bisector of AP. We know A is here, P is already given in the question. P is, here, t square over 8, 1 over 4, t over 4, t square over 8, t over 4. So the perpendicular bisector of AP is another line L2, okay? And L1 and L2 intersect at Q. So to find Q, show that t as t varies, the coordinate Q satisfies this equation. So basically we need to try to find the coordinate of Q. So that's when we frame this equation. To find the coordinates of Q, you need L1 and L2, right? Okay, let's talk about L1 now. L1 is a perpendicular bisector of OA. You see, let's say O is here, A is here, 0, comma t over 8. Perpendicular bisector means a line that is perpendicular to the line OA and passes through the midpoint. So midpoint is t over 16, right? Correct. You can find the midpoint using origin and A. x1 plus x2 by 2, y1 plus y2 by 2. It's going to be 0, comma t over 16. So definitely this equation, because it's parallel to x-axis, y is equal to t over 16, right? So you don't need to show any of this working. You can straight away write L1 is y is equal to t over 16. We got the equation of L1. Now to find the equation of L2, because the L2 is a perpendicular bisector of these 2 points P and A. So it's a perpendicular bisector of these 2 points, perpendicular bisector. So you need this midpoint of AP. Midpoint of AP is equal to x2 plus x1 by 2, y2 plus y1 over 2. right? So this is gonna be t square over 16 comma. So let's calculate this. T, I'm gonna type it without the numbers. 1 or without t. 1 over 4 plus 1 over 8 divided by 2. So it's 3t over 16. That's the midpoint, this midpoint. Now we need to find the slope of this AP, this line. And for the perpendicular line, this line, you take the negative reciprocal. That's the next thing we are going to do. Okay, I have copied this here. Now I'm going to find the slope of AP. y2 minus y1 over x2 minus x1. So I'm going to type this in my calculator without t. So 1 over 8 minus 1 over 4 divided by minus 1 over 8. I'll get positive 1. Basically you will get t divided by t square, which is just 1 over t. That's the slope of AP. So the slope of perpendicular line, the slope of L2 will be negative reciprocal, so minus this. Okay, and it passes through the midpoint, so we can write the equation as y minus y1. This is the point x1, y1. That's the midpoint. Y minus y1 is equal to slope times x minus x1. That's the equation of L2. We already have equation of L1, which is y is equal to t over 16. T over 16. Let's solve these two because Q is the point of intersection. So replace y by this, you will get t over 16 minus 3t over 16 is equal to minus t times x minus t square over 16. T minus 3t is minus 2t over 16 is minus t times this. You can cancel this, it becomes 8. You can cancel minus t. So you're going to get 1 over 8 is equal to x minus t square over 16. Okay. But what are we trying to prove here? We have to prove y square is equal to alpha x plus beta. Alpha and beta are constants. There is no t in there. So from here we can make t as a subject and sub in there. So from equation 1, you can write L1 y is equal to t over 16. That gives us t is equal to 16y. Sub in here. So when you sub in, you're going to get 1 over 8 is equal to x minus 16 square. 256y square over 16. Oh, the 16 can be cancelled. Okay, anyway, make y square as a subject. I'm going to put this term here, this term here. So it's going to be 16y square is 8 minus 1 over 8. Divide throughout by 16. Y square is going to be 1 over 16x minus 16 times 8. 1 over 128. They want us to prove this is equal to alpha x plus beta, and we got the equation. That's all.